case, we had a structural grid of say 9 meters by 9 by 6 meters, so you can get double span CLT floors. And for this, I think we previously had a 240 millimeter Timberlink panel with an FRL for 120 minutes. And when we did the design from an ambient point of view, so the non-fire point of view, it was governing, of course, by vibration on a 240 mil panel. So now we're going to find out what governs the design. Is it fire or is it vibration? So this was just released in the app about 1 hour ago, actually. It's the most recent release. So you can see here, you've now got a new fire design option for floors, a new fire design option for walls, same for columns and same for beams. So I'm going to, right now, fire up the CLT floor fire. And maybe I'll do a quick overview. So if you're new to the app, you can see here, floors, walls, beams, columns, your stud design, which is about to be released as well, connection design, screws, large 1,000 bolts, moment connections coming, and connection details and so forth. So, and Corey is going to share at the end how everyone here can get free pro access for the month of May. So if we go to a floor fire design, for scope, we can go a personal or an enterprise account. So for enterprise, you can actually save it in a company one, which everyone can see. So I'm going to save this in our first webinar. Let's call it for one fire scenario and let it load up. So that's a new release, and you can see here on the right-hand side, we now have a summary button here, which as you're doing inputs, know if it's working or not. All right, so what you're looking at here is a new cross-section of the CLT. You can see what's happening. You've got a plasterboard here as a default input. You've got, it fails at this certain period, and then it burns through for 30 minutes, and then you've got this, this hatch here, which indicates the zero strength layer. And right now we're designing for 5-layer, 135 millimeters based on the manually input buttons chosen. But instead, we're going to go back to our Timberlink panel, and we're going to go to our 7-layer 240. And you can see here, we've got a 7-layer design for 215 millimeters. So if you move through here, there's different options. So we do have the Austrian national annex as the fire option. We've got the draft Eurocode. Well, you got a standard fire test, and that is if you do a real world fire test, you can just input some of those values as well. So, and again, with everything, you've got the more information drop downs, which gives you some guidance on when you might choose both. So for us, as I said, the Austrian national annex is different to the draft Eurocode. So if we input the draft Eurocode, you're going to see a difference in the zero strength layers available. So for us, we're going to do an FRL of 120 minutes. And the dynamic image will populate, and you can see now it's starting to end up with 3 layers of 96 millimeters. With this, we're going to do manual input for the char rate. So right now we haven't wired up all what the suppliers want us to input, but for the moment you can manually input the char rate at say 0.7 millimeters, and everything will update accordingly. So to begin with, we're going to do an unprotected section and see how that occurs. So you can see here, now for an unprotected section, you've got no plasterboard and you end up with 3 layers and 85 millimeters. All right, so this brings us to the new design factors. So the new char factors here, and you can always do more information. So gap, remember I mentioned before, that does influence your gap factor, and it gives you some guidance where you might actually have some sort of sealant to remove the gap altogether. But if you made that 1 millimeters and you solve for a gap, then your gap factor is going to reduce. K3, as well, you can see here that's a multiple factor that actually multiplies for the notional char rate and so forth. So you can always learn about the more information, and we are improving these now constantly, so you can actually learn exactly about everything when it comes to the fire design inputs. All right, so moving down, some of our inputs, we've got loading, superimposed dead load, and live load. Let's just do a 2 kPa SDL plus a 3 kPa live load. We're going to do extended gamma method for unsymmetrical sections and a 6 meter double span section. All right, so 0.7 unprotected, everything like that. All right, so what do we, yep, so 240. All right, so moving down, a few of the other inputs, we got the design factors as well, and that's based on your K factors in the code as well. So moving down, you can see here for our output summary, we are actually working right now at 92% and 28% loading. So if we go through calculation by calculation, Our charring factors, it's not a black box. It gives you very detailed understanding of the K factors, the gap factors, the initial lamination, the phases, the new charring rate in each phase. So phase 1, 3, and 4. And then the zero strength layer right now based on the draft Eurocode, and then multiply there to actually end up with your protection time, as well as getting to the design. So from that, you actually end up with what your end up design thickness is, as is indicated in the image. You recalculate the engineering properties based on the reduced section. You got your loading combinations as well, and then you got your analysis based on the two-span equal, and then finally the design code. So all of that actually behaving quite similar. So let's go back to our design. So right now, extended gamma method, 6 meters. If we go right now to a gap of say, let's say for our design, we're now at a 5 millimeter gap. What happens, you can see here now, we've got the cross here. So we're right now bending in failure. So you can see right now, all of a sudden that's not working. So one of the most exciting things now from our perspective is you can now do a protected layer option. So for this, as I mentioned before, for an protection on the underside, I just click protected. Now you have the ability to actually add protection. So let's go back to our webinar and do some examples. So let's just say on our hypothetical project, the acoustic engineer was exploring 2 options. One was a fully exposed where the acoustic option is on the top side, and the other one is a fully protected solution where the acoustic system is on the underside. So let's say we've already checked the top side or the top option. We're a fully exposed panel. But what about the second option where you've say got a plasterboard, a mineral wool, and then another plasterboard underneath that? So for this scenario, all you need to do is add different layers. So let's just add 1, add 2, and now you've got say 3 layers of plasterboard. That's actually protecting it right now. But for us, we can go to our mineral wool option. When mineral wool is selected, you can input the thickness of mineral wool. And you can see it working dynamically here. So right now, you can see that the plasterboard has protection, and then the mineral wool provides some protection as well for a certain calculated number of minutes, and then the plasterboard, and then it goes through there. So that's one option here. And in the calculations now, you can see in charring, you'll be able to inspect the calculations in detail here. And you'll be able to see the protection time. The plasterboard's 13 minutes, the mineral wool 6 minutes, and then the plasterboard's another 30 minutes all up. And then that's your overall protection time that's now available. So that's one option. And you can save that, and you can print the PDF and things like that. What about, let's do another scenario. Let's go unprotected. So it's going to update like this. So now we end up with an 85 millimeter, and we're failing again because we've lost the protection. Let's say if we maintain the glue line integrity, and I know for sure Timberlink has that, but speak to Timberlink, of course. And you can see that gives you a solid char rate as well. And now we're working again.